Hello, this is Mr. Flatness, and today's focus is division of decimals, specifically dividing decimals by whole numbers. We will start out today's lesson by looking at some vocabulary. There are 3 words specific to write down in your notebooks, along with the picture of the example here that you see. So please do so in your notes. Within a division problem, we have 3 things to identify. The number that is inside the division symbol, here's your division symbol, the number inside of that is called the dividend. A dividend is the number that you would like to split up in a specified number of parts. Basically, it's the total amount that you want to split up. Outside the division symbol is the divisor, and a divisor is how many equal pieces you would like to split the dividend into. So here I want to take 460 things and split it up into 5 equal parts. The answer, which is on top of the division symbol, is called the quotient. So if I took 460 things and split it into 5 equal groups, there would be 92 things in each group. Let's look at division a different way. Here I have the same exact problem, but I wrote it differently. Notice I have 460, and then I have a diagonal line. The diagonal line is your division symbol. Then I have 5, and that is equal to 92. So when a problem is written this way, when you divide, the first number is called your dividend, your second number is your divisor, and finally, the number to the right of the equal sign is the quotient. So just a second way to write a division problem. Again, I'm taking 460 things, dividing them into 5 equal parts, and there's 92 things in each of those 5 groups. So to transform this division into a traditional division problem that you would work out on paper, you would say 460 and write that down. Then you would put your division symbol, so the dividend goes on the inside, and then my 5 would go on the outside. A final way to write a division problem looks like a fraction. Notice I have a top number as 460 and the bottom number as 5. So within a fraction, 460 is my dividend, my fraction line is the division symbol, and the bottom number is my divisor. To rewrite this problem in the traditional manner, we would take 460 again and put it on the inside, divided by, and then we would put the divisor 5 on the outside if I wanted to solve for this. Please make sure you put all 3 examples into your notes for future use. The next thing we're going to talk about are the steps for how to divide. As a 6th grader, you should know how to divide with long division, so these steps should be a review for you. So the 5 steps are as follows. Step 1, divide. Step 2, multiply. Step 3, subtract. Step 4, check. And step 5, bring down the next number. To the right, I've put down a mnemonic, and a mnemonic is basically a phrase that we can set up that helps us remember the original steps of divide, multiply, subtract, check, and bring down. So my mnemonic is, does McDonald's serve cheeseburgers? And you'll notice that when you look at the first letter in each particular word, they match. So divide and does relate to one another. Both these help you to determine that that's how to divide, or that's the step to divide. Multiply and McDonald's match. Subtract and serve. Check and cheese. Bring down and burgers. So this mnemonic of does McDonald's serve cheeseburgers helps you to remember the specific steps of division and in their specific order. Please write these steps down in your notes. In our first problem that we're going to look at, we have $3.75 divided by 3. The first thing I'm going to do is write the mnemonic down to help me remember, does McDonald's sell cheeseburgers? Or does McDonald's serve cheeseburgers? That helps me to remember all of the steps necessary. The next thing I'm going to do is rewrite the problem so I can solve it traditionally. So $3.75 is my dividend, so that goes on the inside of the division symbol. 3 is my divisor, so that goes on the outside of the division symbol. Step 1 is to divide. Will 3 go into 3? And we would say yes, 3 goes into 3 one time. So there's my division. 3 goes into 3. Step 2, multiply. 1 times 3 would be 3. So I would put my answer underneath the first 3. 1 times 3 is 3. Third step is going to be subtract. 3 minus 3 is 0. So I'll put a subtraction symbol in there and 0. Next step, check. The check piece is when after I subtract, I need to check to see if that number is smaller than my divisor. This number here always must be smaller than the divisor. Otherwise, if it isn't, this answer then is wrong and needs to be bigger. So I know that 0 is smaller than 3, which means now I can bring down my next number. So that's step 4, bring down. So in this case, I'm going to bring down the 7. So I'm going to take the 7 and bring it down here. I also like to use a line, shows that I'm bringing that number down. Okay, after I bring down, now I'm going to go back to the original beginning. So once I'm here to bring down, I'm going to go back up to step 1 and repeat the process all over again. So 3 goes into 7 2 times. So I'll put my 2 up there. Then I'm going to multiply. 2 times 3 is 6. Notice I'm going to put the 6 right underneath the 7. After that, step 3 is subtract. 7 take away 6 would be 1. Check. Is 1 smaller than 3? Once again, it is. Therefore, I can go to the last step, which is bring down the 5. I'll go back to the beginning. 3 into 15. 3 goes into 15 5 times. So I'll put my answer right up there. Then I will multiply. 5 times 3 is 15. So I'll put 15 down there underneath there. And finally, I will subtract. 15 take away 15 is 0. And what you'll notice now is that I have 0 as a remainder, and I have no more numbers to bring down. I know that 0 is less than 3, so I divided it correctly. Therefore, I'm done solving the problem with the division part. The one thing that I should have done sooner was to put the decimal point straight up in my answer. Here was the decimal point, $3.75. We're going to raise that straight up in the answer so that I have my correct answer when I do that. So $3.75 divided by 3 would give me $1.25. And then I can use estimation to think if that's correct or not, because when I look at these numbers, I can round the 375 down to 3. $3 divided by 3 people is roughly $1. And my answer is roughly $1, $1.25. Therefore, that I can justify that this answer to be correct. Here's a second example, but this time you'll notice that my divisor is a 2-digit number. I don't do anything different. The first thing I have to do is take the division sentence 55.08 divided by 17, and I need to rewrite that so that I can solve it traditionally. So the first number goes on the inside, 55.08 divided by 17. And again, I'm going to over here, does McDonald's serve cheeseburgers? That helps me take care of the order and how to solve this particular problem. Now in this problem, we have a two-digit divisor, and for a lot of students that's more difficult because now it's harder to rely on basic facts. So for students asking themselves how many 17s go into 55, for some students can be more difficult. So what I like to do is use compatible numbers, rounding and estimation to help me through the process. But first, the very first step I'm going to do is I'm going to take the decimal point right here and I'm going to move it straight up in my answer. So I'll get that taken care of right away. Now I'm going to use some estimation. So I take a look at 55 and 17. 17 is a number I'm going to adjust first. 17 is very close to 20. So when I look at how many 20s get me close to 55, I can take 55 and round that up to 60. So I can count by 20s quite easily, and I should know that there are 3 20s in 60. So what I'm going to do is try 3 17s into 55. So that was my divide. I'm saying 17 goes into 55 3 times. So next step, I'm going to multiply. 3 times 7. 3 times 7 would be 21. And 3 times 1 is 3, plus 2 is 5. So 17 times 3 is 51. So there's my multiplication part. Now I'm going to subtract. 55 take away 51 would be 4. So after my subtraction, I'm going to check, is 4 smaller than 17? Yes, it is. So now I can bring down the 0. And I'm going to repeat my division steps again. So how many 17s go into 40? Well, I can also think about, changing 17 again in my head to 20. How many 20s go into 40? Well, that would be 2. So I'm going to try 2 up here. 17 times 2. 2 times 7 would be 14. So I'll put the 4 down there. And I'll get rid of that 2 so I don't make a mistake with it later. Put my 1 up there for 14. And then 2 times 1 is 2, plus 1 is 3. So 17 times 2 would be 34. I'll subtract. 10 take away 4 is 6. I'll check. Is 6 smaller than 17? Yes, it is. Next I'll bring down, or finally, I'll bring down the 8. And then I'll ask myself again by dividing, how many 17s go into 68? Well, I would think about, how many 20s go into 70? So I'm going to try, that's between 3 and 4. So I'm going to try 4 just to go a little bit higher and see what that does. 4 times 7 is 28. There's my 2. 4 times 1 is 4, plus 2 is 6. So 17 times 4 is 68, and I get a remainder of 0. Also, there are no more numbers to bring down. So what I can say is that 17 goes into 55.08 3.24 times, which makes a lot of sense because earlier we talked about estimation in compatible numbers. 17 is close to 20 and 55 is close to 60. How many 20s are there in 60? Well, that would be 3. So therefore, my answer of 3.24 is very close to 3. So therefore, I can justify that my answer is correct. Our last problem is a real-world problem that I can use division to apply to a situation. So I have a table, and I also have the word problem. That reads, Meg is purchasing lumber to build a porch. The table shows the cost of the boards. So looking at the table, we have the length in feet, and here are the numbers. So how many feet of board am I going to buy? And then here's the cost for that particular amount of feet for each one. So for 6 feet, I would have to pay $3.56. For 8 feet, I would have to pay $4.66. If Meg buys 12 feet of board, how much would it cost her per foot? The word per is a very, very important word. The word per tells me that I need to divide. So, I want to know what's the cost per foot. The cost per foot. This helps you to set up the problem correctly. A diagonal line is another way to say the word per. And we also know that a diagonal line talks about division. So the cost is the first number, $6.48, per, well, here we have 12 feet of board. So I can rewrite this using traditional steps. So I'm going to take $6.48 and I'm going to divide it by 12. Now here again we have a double-digit divisor in 12, but 12 is a nice number to work with because this is a basic fact number. So we should be able to divide this pretty easy without estimating, but if you don't know your 12 facts, you should also think about, well, hey, 12 is close to 10. And then how many tens are in 648? Okay, well, 648 we can also take a look at as 600. In which case, how many tens are in 600? Well, that'd be 60. So I should be getting close to that number with my digits. The other thing we have to look at is the decimal. So I'm going to take that first and I'm going to put it straight up in my answer. So now it's not really 648, it's 6 4800ths. So I can use estimation to know that, hey, 6 is half of 12. So how many 12s go into 6? Well, that'd be about a half. So another way to think about that problem using estimation. But we're going to traditionally divide to find out our answer. So I'm going to divide by asking how many 12s go into 6. There aren't enough 12s go into 6, so I would put a 0 out front here. So then I would move on to say, well, how many times does 12 go into 64? And 12 goes into 64 5 times. 12 times 5 is 60. So that's the next step, multiply. So 5 times 12 is 60. I will put my answer straight down here. And then I'll subtract. 4 take away 0 is 4, and 6 take away 6 is 0. Is 4 less than 12? It is, so there's my check. And then my next step to bring down the 8. How many 12s go into 48? That's another basic fact. 12 goes into 48 4 times, and 12 times 4 is 48. So my remainder is 0. 0 is smaller than 12. And I know that I have no more numbers to bring down. So the answer that I would get then, how much would it cost per foot? Well, the answer here that I have is in money. So 0.54 would be the same thing as saying 54 cents. So I could either write it like that, or I could write it like this, with my decimal point being right in there, not there. So, to review, we looked at vocabulary with division and specifically knowing what number is the dividend, what number is the divisor, and what number is a quotient. We learned the steps on how to traditionally divide with long division. And then we also did some examples and worked through a real-world problem. Basic fact knowledge is extremely important in long division. And so if you don't know your basic facts, that takes the steps of long division and makes them much longer. So for division, and specifically long division, to go faster, it's important that you can use estimation and your knowledge of basic facts to make it go quickly. You will also be accurate as well.